So first unit already just yesterday we have discussed about syllabus. Today we will start the first unit. Okay, I will maximize this. Okay, just a second, please. So okay, introduction to quantum mechanics. So introduction to okay, introduction to quantum mechanics. I am writing shortcut. Okay, and also please maintain running notes. Okay, I will explain detailedly, but you write main points. Okay, if it is there is a theory, equation part, you completely write down because in notes, if you see, if you have running notes, you can see sometime in free time, 1 2 minutes also. If you see, you can get the answer. Okay, so introduction to quantum mechanics. So before going to quantum mechanics, generally physics this is also one physics topics like classical mechanics, quantum mechanics, and this is also one of the physics topic only. First we have classical mechanics. Okay, classical mechanics, and earlier we used to explain the what is the classical mechanics means. Already I discussed yesterday. So it discussed the about motion and behavior of the behavior. Okay, motion and behavior of what macroscopic bodies. What is that? Macroscopic. So macroscopic bodies, like suppose you are going on the vehicle, suppose you are going on bike. So how much speed this bike is going? Okay, what is the motion of, what is the nature of the this vehicle or motion behavior? Okay, how it is moving, speed and acceleration or trajectory, you can study the using classical mechanics. Okay, mainly it discuss about the motion and behavior of a macroscopic bodies. Means macroscopy means objects we can see with human eyes. And also you can see, you can study the planetary motion. Suppose we know all planets are revolving around the sun, right? Planetary motion, how these planets are revolving around the sun. Okay, what is the speed of these planets also we can study the using classical mechanics. Okay, this is the some so mainly classical mechanics used to study the macroscopic bodies. Okay, are planetary motions, that is we can see human eye, right? So this is the classical mechanics. Okay, now why this quantum mechanics came? Okay, quantum mechanics. So in 1850s, so this black body problem is came. Okay, black body problem. Okay, what is this black body problem or black body radiation problem, whatever? Okay, so suppose when once these planets are revolving around the sun, right? So in that case, there is a some discoveries of black holes. Okay, black holes. And also if you go into the universe, it is completely black. We cannot see anything. It's a completely dark. Suppose in that case, or in that planets they are dying. Black holes means dying planets. Okay, that after dying, that planets look like completely black. Okay, no, nothing will we can see. So in that planets, if you shine some light or if you send some light, okay, what happens? Okay, what happens to that black body? Okay, if you shine some light, nothing is observing, nothing is we are collecting. So what is happening to that body? For that studying that black body, that black holes, these scientists what they have done, they have artificially created some black body. It is also look like it also follows same properties of a black holes. Okay, similar kind of object or body or something like that. Okay, from there they send the light and they absorb different phenomena. Okay, that is the black body. But using this classical mechanics, they could not explain this black body problem. If you send some black body, suppose any body it is completely dark. Okay, so they cannot explain using classical mechanics. And also suppose if any object it's moving with a velocity of light. Okay, velocity of light. So this using classical mechanics laws. Okay, they cannot explain the motion of this object or any particle or material or anything. Okay, they cannot explain the moving object with a light speed. Okay, that is also one problem. And also another failure. So sorry that one note is gone, right? Just sorry for that. So just a minute, please. So can you see PPT? Hello?
Yes,
Hello?
sir.
Sir,
Okay. So sorry for that
yes,
interruption. Okay. So and also, suppose if you came into atomic level, suppose we know a nucleus is there, after that electrons are revolve around the nucleus, right? So using this classical mechanics laws, classical physics laws, so they cannot explain how these electrons are revolving, how this nucleus is staying stable, and why this electron is not falling into the nucleus. Okay, these phenomena they could not explain using classical mechanics. That's why this quantum mechanics came into picture. Okay, so what is the quantum mechanics? Before going to complete detail, what is the quantum mechanics? First one, so it discuss about the energy and matter. So classical mechanics failed to explain these phenomena, these problems. So this quantum mechanics came into picture, and to solve that problems, another subject, another laws, some different kind of laws came into picture. That is the quantum mechanics. Okay, this discuss about matter, energy and matter of a in terms of or on the scale of microscopic level on the scale of microscopic. Microscopic means this is atomic scale. Microscopic means what is the atomic size? Microscopic bodies are any material or particle, whatever. Okay, what is the atomic size? What is the atom size generally? Order of anyone, please? Atomic order 501. Are you there? Anyone, if you
Central
know?
Population.
Yeah, good. Who is that? What is his name? What is your name?
Kiran, sir.
Kiran, huh?
Yes, sir.
Okay, good, thank you. Okay, that's good. Okay, atomic size is 10 power minus 10 meters. Okay, this is the atomic general order of the atomic size. Okay, so in terms of, if you go the size of bodies, if you have some more, suppose you have cricket ball, if you reduce the size like very small, like 10 power minus 10 meters, that much size. So using classical mechanics, they cannot explain the this atomic level. So here microscopic means atomic or subatomic levels. Okay, using class quantum mechanics, they discussed mainly behavior of matter and energy, or interaction of energy with matter. Okay, interaction of energy or interaction of radiation with matter in the scale of microscopic level, that is 10 power minus 10, order of minus 10 meters. Okay, okay, that is the quantum mechanics. Okay, using this quantum mechanics, they explained several problems. Quantum mechanics, this black body radiation, photoelectric effect, and this thing. Okay, here also in this 1850, this black body radiation problem came. Okay, using this quantum mechanics laws, they uh, able to explain the black body radiation. Next topic is black body radiation. We will discuss completely there. After that, in 1950, that one is came. After that, in 1985, okay, 1985, okay, they slowly at a time this quantum mechanics not developed. So in the 80s they started the uh, they faced some problems in classical mechanics. Using classical mechanics law, they faced some problems. So slowly they discovered new things. Okay, new things. Then this slowly this quantum mechanics developed. Okay, in 1885 they Hertz discovered photoelectric effect. Hertz discovered photoelectric effect. We have next in the topic photoelectric effect. What is the photoelectric effect? We will see. When you shine the light on the material, it emits the some light. Okay, it emits the some electrons, stream of electrons. That is the photoelectric effect. We will see that one. Okay, after that, 1885 they discovered this thing, and in the 18 many theorems are there. Okay, in 1900 new era is started. In 1900 new era started. That is what is that what discovery is done in this year. So Planck's radiation law, this is very important law in quantum mechanics. Planck's radiation law. So what is the Planck's radiation law? So in this law, what they have done, earlier they don't know how the energy is distributed, how the energy is releasing, they don't know. So radiation, once radiation interacts with matter, so energy released in the form of or whatever energy released in the, once a radiation interacts with matter, some energy is released. Okay, that is quantized. What is the proposed? That energy is quantized, are amounts of discrete energies. Discrete. Okay, it released as a discrete amounts. Okay, discrete amounts means suppose 1 2 like that, 1 2 3 4 like that. Okay, so once radiation interact with matter, some energy is released. Okay, that energy exchange are released or absorbed, whatever that one, the energy exchange is quantized. Okay, or it released or absorbed in the form of discrete amounts. Okay, that is one postulate, a very important postulate he proposed. After that, second one is whatever exchanged this energy. Okay, exchanged energy, what is the, what he called this one, a quanta, energy quanta or quantum, whatever you can say. Okay, quantum or quanta also you can write, quanta, energy quanta. This discrete amount we called a energy quanta or quantum. Okay, second one, this energy released in the multiples of integral multiples of h nu, integral multiples of h nu. This is also very very important postulate we proposed. The released energy or exchanged energy released in the form of h nu. N is the integer like 1 2 3 4 like that. Okay, 1 2 3 4 like that. So okay, what is the smallest energy in this case? Smallest energy is h nu. Okay, h nu, this is the smallest energy. Okay, once the radiation interact with matter, the exchanged energy is h nu, that is very very smallest energy. That is h is the Planck constant, nu is the frequency of that radiation. Okay, or wavelength. Okay, this is the lowest energy. Okay, this energy we are calling quanta. Okay, or quanta or quantum of energy. Okay, this is two important postulate we proposed. Okay, next one, after that in 1905, what Einstein proposed? Relativity theory, Einstein. Okay, already you know, I think, what is the relativity theory? Einstein relativistic theory.
is equal to mc.
Yeah, that is good. Okay, this relativistic theory, what this discuss. So suppose suppose we have how the bikes or any car will go, like suppose 100 kilometer per hour or something like that, right? So suppose if you send any object with light velocity. Okay, if you send any object with light velocity, what happens to this object? How the trajectory or behavior of this particle will change? That is the relativistic theory explains. Mainly relativistic theory explains the, suppose if you send any object with light speed or light velocity, so what happens to that particle, or what is the trajectory or behavior of that particular matter? Okay, that is he proposed. Suppose in here also, light, we know light is also itself a light itself a em wave. Okay, em wave, or it is also quantized like a energy. It is also quantized like what Planck proposed. This light also quantized, or it travels as a teeny particles. It travels as a particles teeny particles. From there he proposed photons. Okay, this teeny particles, what he named it? Photons. Photons means it is a light. Simply, if you can understand, photons is nothing but light. Okay, what he proposed, just light also itself of a made up of a teeny particles, or this also quantized like a electromagnetic waves. This is he is calling a photons. Okay, after this also lot of changes came into the picture. So in 1910, I think 1910, what Rutherford proposed? Rutherford, anyone? What is the Rutherford model? What he did?
Alpha particles scatter.
Yeah, good, very good, very good. So he discovered the nucleus, right? Nucleus. So yes, suppose there is a nucleus and the electrons revolve around the nucleus. Before this 1911, we don't know there is a nucleus exists in every atom, or electrons revolve around this nucleus. We don't know. But in 1911, this Rutherford came and he proposed this nucleus. This nucleus are existing and electrons also revolving around this. And after that, 1913, and Bohr's also came. Bohr orbital model. This is, he proposed to, suppose hydrogen he took, for hydrogen he proposed the atomic hydrogen model. Okay, these are the some postulates. After that, this 1923 1923 another great discoveries came, that is de Broglie hypothesis. What is the de Broglie hypothesis? Already you know, I think, de Broglie hypothesis, he proposed the matter waves. Okay, matter waves. What is matter? What is mean by matter?
Anything that occupies space in the world.
Anything?
That space,
Yes, please. Some you are saying, but I cannot hear you. A7.
anything that occupies space and has mass is called as matter.
Yeah, okay. So any substance, okay, any substance they are that is having some mass, okay, that is the matter, okay. So in 1923, he proposed dual nature of matter, okay, dual nature of matter waves or matter, or you can say you can write dual nature of matter. So matter is just nothing but a substance which is having some mass, okay, mass, and it will occupy the some space. That is the matter, okay. So in dual nature before 1923, what they someone said, this light is propagate as a particles, and somebody said it is a wave nature, okay. There is no clarity between this concept, okay. After that, in 1923, de Broglie proposed every material particle behave sometimes wave nature, sometimes as a particle nature, okay. This is also one of the great discovery in quantum mechanics. After that, there is a like 1924 Eisenberg model also came, Eisenberg, and after that in 1926 Schrodinger wave equation. Okay, he explained in the form of Schrodinger wave equations. Okay, suppose electron revolving around the nucleus. Okay, what is the wave function of these electrons he proposed? Okay, like that he explained in the form of waves. Okay, wave nature. You considered wave nature of the electrons or particles, any microscopic particle. He explained. After that, in 19 I think 28 something like that, somebody explained with particle nature, and somebody explained wave nature. Okay, in 1928 Dirac came, and he also proposed matrix method. Okay, matrix formulation. Okay, this is also in PG syllabus known it. Okay, these are the some starting onwards 18th century to 19th century, some of the great discoveries in quantum mechanics. Okay, first these are the some important discoveries in 19th century. That is one of the main important postulates Planck's proposed, that is Planck's radiation law. That is also very important topic in quantum mechanics. In the first unit we will discuss that is clearly. After that, this 19th century, 1911, they proposed nucleus and atoms and this thing. After then only we came to know nucleus is existing every atom, and electrons are revolving around the nucleus, and atomic configuration, electronic configuration, this all came into picture. There is a lot, this quantum mechanics also expand hugely. And after that, in 1923, de Broglie proposed dual nature of matter. Okay, that is also very important theory. So we'll discuss one by one. Okay, now we'll discuss black body problem. Okay, what do you know about black body? Anyone? Black body?
It absorbs anything to into it, sir.
Okay, very good. Okay, what's your name? May I know your
Tirupati,
name? Huh?
Tirupati, sir.
Tirupati. Okay, good. Okay. So black body is you can already see black body means it's nothing is just like you are seeing. Suppose in your laptop or monitor, how it looks black. Okay, your board in classroom, your board is black. Okay, these all are black only, black body. Suppose if you shine some light, anything you will not observe, right? Suppose why your shirts and your pants are coming different colors. Suppose your bike or your any tools different colors. Suppose your shirt is there, it is cover, suppose it is looking a red color, it is a, you have purchased in the shop red color shirt, why it is looking red? Or suppose any blue, suppose any blue light, any blue shirt, so why it is coming blue and red? Why it is showing only that color? Why not in a energy? What is the spectrum actually? What is the energy spectrum? Before going to this, what is the energy spectrum? Anyone? Spectrum of wavelength or any spectrum? Don't know.
It means
540.
it's a
Ah,
beam
yes,
of
please.
different color of lights.
Yes. So okay, good. So 540, are you there?
Yes, sir.
540. What is the spectrum means? What type of wavelength you can see? So generally you are seeing things, right? Which color you can able to see in generally? Generally, suppose huh? So generally we will see visible light, right? Visible light. You already know,
Yes,
but
sir.
you are not answering. Generally, so
Yes,
what
sir.
we are
Visible.
seeing, yeah, what we are seeing with the human eye, that is visible light. Okay, but
Yes,
in
sir.
generally the energy spectrum is UV, visible, and infrared. Okay, IR. Okay, these are and also there, but this is a very important spectrum. So this is like 200 nanometer, and visible is like 350 or 350, around 350 to 800 or 850 nanometer. Okay, IR is beyond this one. Okay, this 350 to 800 nanometer only we can see, that is VIBGR, right? VIBGR. So these colors only we can see with naked eye. So you have already seen when prism is there, if you send some white light, you can see here multiple colors, right? Because dispersion of this light. Here also, why your set is looking red, why your set is looking blue means, so it will absorb remaining colors in the whip jar. Suppose we have how many colors? 1 2 3 4 5 6 7 colors, right? Whip jar in the seven colors. So suppose your shirt is red, so this is absorbing all this violet, indigo, blue, green, yellow, orange. Okay, only it will reflect red. And if it is blue means it will reflect only blue, remaining it will absorb. That's why only we will see one color. So here also black body means, here black body means, so it will also, it is a simple some black object or black body, it color is dark, completely dark.
Emitted.
Yeah. So if you shine any light or if you incident any light, so it will completely absorb. This object completely absorb, and it will not emit any radiation. Okay. That is why it looks like a block. Okay. What is the definition of block body? The body which absorbs the complete light, whatever incident on the that body. Okay, that is the block body definition. Okay. So you can write the block body definition. Okay, what is the block body definition? Why do you got it?
The body which absorbs complete light.
Yeah, the body that absorb the complete light, whatever incident on the body. Yeah, okay. You can write a definition. You can easily write. Okay. So this is the black body. Okay. What is the radiation or what is the thermal radiation? Okay. We are going to discuss black body radiation problem. In that we are just discussing what is the black body. Black body is just simple body. It is it when some light is incident on that body, it absorbs the complete light and it look like a black body. Why it is look like a black, we'll discuss. Okay, now before going to that problem, we will see some definitions. Okay, what is the thermal radiation? Okay, what is the thermal radiation means? It emits the radiation. Okay, emits the radiation by some some source of temperature. Okay, source of, okay, you write spelling properly. SOURC. Okay, source of temperature. Okay, source of by which of temperature. Okay, suppose you heat the body, it will emit the radiation. Okay, so source of it is thermal radiation means it emits the radiation by source of this temperature. Okay, so now what is the definition of radiation? What is the definition of radiation? 539, 539, 539, are you there? 539.
Yes, sir.
What is the radiation?
Radiation.
Generally you know radiation. You generally you talk about, no, when you buy the phone, mobile phones, you will see this is radiation, it will
Sun radiation.
harm the our body, and this thing you will read, right? Radiation means what is that? So radiation is just very simple. So
It is a
emission
type
of,
of energy.
yes, yes,
It is
this,
energy that comes from
Energy
source
in terms
uh,
of light waves.
and travels through.
okay, okay, right, very good, both are correct. So very good. Okay, it is a simple radiation means emission of light, emission of energy, emission and propagation of propagation of energy, energy in the form of in the
Waves.
form of waves or EM waves, whatever. Okay, depends on our topic where we are discussing. Depends on topic. Okay, radiation is simple as it is a emission of energy and propagation of energy in the form of waves or EM waves. Okay, that is a simple radiation means. Okay, so thermal radiation means if you heat the body, or if you heat the body, or if you give the some if you heat the body, that will get temperature, will measure the heat by temperature, right? So that will emit the some energy or release the energy, that is the radiation. Now what is the definition of black body radiation? You can know, you can black body radiation, you know black body, you know radiation. What is mean by black body radiation? Please come on.
Neither reflect nor transmit, but absorbs heat radiation.
Neither reflect, please
Neither
tell.
reflects nor transmit, but absorbs heat radiation.
Okay, it will neither not it will absorb, not neither, it will absorb complete
The
light and
body
it
which
will.
absorbs
An
complete
object that absorbs all radiation
instant.
falling on it
Yeah,
at
yeah,
all
yeah.
wavelengths.
Yeah, good. Okay. It is simple. Okay. The black body which emits the radiation. Radiation means it emits the energy. Okay. It emits the energy. How it will emit the energy? If you heat the body, if you heat the body, it will emit the energy. That is the simple black body radiation. Black body, you know definition. The body which absorb the light when
Light,
incident when light are okay, light are some light.
whatever
Okay.
instant on the body
Yeah, yes, yes, good.
at
Okay,
all
whatever incident,
wavelengths.
yeah, that will absorb, right? So that is the black body radiation means it emission of a energy, emission of energy. So black body radiation means the body whatever which is absorbing the light, right? Whatever incident on. So after that, if you heat that body, it will emit the energy in the form of EM waves or waves. That is the black body radiation. Simple, right? You understand definition, right? So just you no need to by heart this definition, just you understand by word. Suppose first you understand black body, then after that radiation you combine these two, then you will get the definition, just as simple as. Okay, that is the black body radiation. Now we are going to discuss this black body radiation. Simply, the body, the black body which emits the radiation in the form of EM waves. Okay, how that will emit? If you heat that body, initially that will absorb whatever light incident on that body, it will absorb. Once you heat that body, it will emit complete spectrum of light or complete spectrum of energy. Okay, that is the black body radiation. Now there is no ideal black body, but we can create some artificial black body. Suppose in our home, in our home also generally you can say some black things. Okay, or you can say lamp black, black. Okay, or whatever we are using lamp, after running this lamp we will see some blackish things. Okay, this is act as a 99% black body. Okay, 99% a black body. Okay, we don't have 100% black body, and also this is how we can create the black body, we'll see now. Okay, just a second, I'll take the page. Okay, now black body, just they will take a hollow sphere here, that a hollow sphere. Okay, this is some hollow sphere. Okay, here hollow sphere means nothing is there inside. Okay, just empty hollow sphere. They will keep a very pinholes here. There is a small pinhole here. Okay, pinhole, and here coated some metal coating or some metal or lamp black they will coat here, because on this top side surface. Okay, this surface of the hollow sphere, inner surface. Okay, so here you can send the light, right? Here you can send the light. Okay, this is some incident light you are sending through the hole. You are sending some incident light through the hole, and after that this light will hit in the surface and it will reflect back. Maybe it will reflect this direction also, maybe in some other direction also. This will it will the same direction also, maybe other direction also. But we are not, this is hollow sphere, there is very less probable to same back scattering or back same direction, it will reflect in a very less probability. So it will always reflect in different direction. Okay, after that here also it will hit and it will reflect another direction. Okay, after that it will again hit the some other direction and like this. So it will, once the light incident on the this inside the black body or hollow cavity. Hollow means just empty, nothing is there inside. Okay, that is a hollow. Okay, cavity just created inside, they coated with lamp black or some metal coating. Okay, and they send the incident light, some light here. This light, whatever incident on the inner surface, this will reflect back and it will hit on some surface. After incident here, it will, some of the light will absorb here. Okay, some of the light will absorb and some of the will reflect back. Okay, after hitting here next place, here also some of the light will absorb and again reflect back. Okay, and in multiple reflections, some of the light will be absorbed. After some time, after some instant of time, this total light will be absorbed within the cavity, within the this hollow sphere or hollow cavity. So how we are making here black body, just we are taking a hollow sphere. Okay, inside we are coating some metal or some carbon block, something like that. Okay, we are sending a this incident light. Okay, we are sending some incident light. This light, whatever incident on this metal surface or some surface of this cavity, some portion of the light will be absorbed and it will reflect back. Whatever incident on inside the surface, some of the light will absorb, some of the will reflect. Like that, this total light will be absorbed within the material. Once this light is absorbed, it looks like a dark. Okay, it looks like a dark color. Okay, then we can see it is a black body. It is a black body. Suppose it's a simple example. If you take any room, you switch off all lights. How it is looks like? Completely dark, right? How it is
So,
look like? Yes. Any doubt?
so can you give any explanation, sir, to write to note down?
Black body. Which?
Yeah, so you are saying, sir.
Okay. This black. Okay. Definition is just I am explaining. You can rewrite whatever whether right or wrong. You write down just black body. Just we are how we are creating black body. Just we are taking a hollow sphere. Okay, inside the surface, hollow sphere means just a empty sphere. Empty sphere. We are making small hole here, pinhole, small pinhole here, and inside the surface we are coating with some metal or some carbon block. Okay, to absorb this light. Okay, after that we are sending some light to inside the black ball through this pinhole. This using only this pinhole, we are sending some light. First it is hitting, suppose we are taking position 1, that hitting on position 1, here some light is observing and some light is reflecting back. Next take position 2, here position 2 also some light is observing and some light is reflecting. And next it is hitting on the position 3, here also some light is observing and some light is reflecting. Like that, different positions, it light will be, portion of the light will be absorbed. At the finally, at the end of the time, we don't have any light to reflect back. Okay, total light is absorbing within the material. Once that light is absorbed completely, so it looks like a dark color, that is black body,
Dark.
we are calling dark. Okay, that is just example. Just take any room, if you switch off all light, it looks like a dark. This is also same kind of thing. Okay, so once you send the light, it will completely absorbed by multiple reflections within the sphere or within the hollow cavity. That is the black body. Okay, now this is the black body. It is absorbing complete light. So how it is emitting the radiation? How it is emitting the radiation? So this black body, what we are doing? We are heating this black body. Okay, so just without doing anything, it will not emit, right? It will not emit any radiation. So what we are doing to emit the radiation, we are heating the body. We are giving some temperature to this body. With increasing this temperature, some uh, slowly this light will emit. Okay, slowly this radiation will emit from the black body. So simple example, so once it will start slowly, it will intensity also increases slowly. If you give less temperature, suppose 100 degree centigrade, less intensity will be there. if you increase this temperature, this intensity of releasing energy or energy density or emitting energy density also increases. Suppose when you see if you switch on incandescent bulb, what happens? Incandescent bulb. Okay, incandescent bulb. So if you switch on incandescent bulb, first it will looks like a red color, right? Incidentally, it will looks red. After that, slowly that color will also change. Finally, how it looks like? White. Okay, red. After that, green, blue or green, like that. Finally, you will get the like bluish white color. You will see here also. If you increase the temperature, if you heat the body, okay, it will emit the radiation. Okay, how it will emit the radiation? Once it is completely absorbed, once you incident the light, but how it will emit? If you heat this body slowly, why this emitting the radiation? Anyone? Why it is emitting the radiation? So okay, no problem. Okay, whatever electrons on the surface, they are getting some thermal energy, right? They will vibrate to and forth. Okay, they will vibrate to and forth, and they lost the energy. They lost the energy, and this is the what we are saying radiation means. Okay, how we are getting radiation? By giving temperature, whatever electrons on the surface getting thermal agitation, and they are releasing the energy. Okay, tomorrow we have I think time is up. Okay, shall I discuss one more minute? Hello.
Okay, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay, once this whatever electrons, whatever they get energy from heating, we are heating the black body. These electrons getting some energy, and they will move or they will vibrate to and forth, and they will lose the energy, and that radiation will emit from the black body. That radiation will emit from the black body. If you plot the graph, okay, this is the wavelength. Suppose in take a nanometer, or you can take micrometer, whatever. This is the emitting energy density. Emitting energy density, or energy density, or you can write radiation also. Energy density, or you can write radiation also. Whatever you can write, they both are same only. But just energy density or radiation. What is the units? Kilojoule for meter, or nanometer, or you can like that, or millimeter, whatever. Okay, kilojoule for meter here units, radiation units. Okay, if you increase the temperature, its spectra is looks like a like this. Okay, this is suppose 2000 Kelvin. Suppose 2000 Kelvin means what is the in degree centigrade? Minus 273 you have to subtract, right? That is the in degree centigrade. Okay. So if you increase the temperature, this intensity also increases. Intensity also increases. Like this, intensity also increases. Because if you are giving more temperature to that body, right? If you give more temperature, more electrons vibrate to and fro, more electrons lose the energy, and emitting energy intensity also increases. That is the, if you increase more temperature, the intensity also increases. Emitting this black body is emitting some radiation, right? That intensity also increases. Okay, no problem. We'll discuss tomorrow. Okay, yeah, I think it's break time. Okay, is it clear today class? Everyone, do you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. If you have doubts, you can ask me anytime. Okay, then I'm closing the class. Okay. Okay, bye. Thank you.
Thank you, sir.